Visualizing Hypotheses Testing by Judy McClendon Redmond. On the agenda, we have the visualization number 1, test for a mean, visualization number 2, comparing two groups, visualization number 3, efficiency comparison, visualization number 4, correlational tests, and the important takeaways. On the visualization number 1, test for a mean, we see that the mean is the average for a set of figures, which is on this bell curve, that is the highest point, and that is considered the mean. On this, there's a research question that asks, on average, are the widgets from the Acme Widget Company defect-free? The answer is on the null hypothesis, no. On average, the widgets from Acme are not defect-free. On the alternative hypothesis, the answer is yes. Widgets from Acme are defect-free. And as you will see, for every 100 widgets, the mean is 0. This rejects the null hypothesis. Therefore, the wedges are defect-free, as the answer states. On visualization number 2, we are comparing two groups. If you would notice, there are two bell-shaped curves, and they're indicating the minor league, which is in the red curve, and the major league, which is the blue curve. And on the left side, it shows the number of home runs, but at the bottom of the chart, there's a fraction of teams that are home run hitters. And now this in the blue, it shows the means at the highest, and on the hypothesis, we will reject the null. The two curves, they show that the blue is higher. And on the question, it asks for the comparison. Does the average major league team have more home run hitters than its corresponding minor league team? The null hypothesis answer is the average major league team has an equal amount of home run hitters to the minor league team. And on the alternative hypothesis, the major league team has more home run hitters than the minor league team. On visualization number 3, it's called the efficiency comparison. And on here, we have more factors involved, and it is a comparison of two teams, a blue team and a red team, with this mixed data. These we have two bell-shaped curves with noticeable differences. One shows us 10 hours in red, and one shows 4 hours in the blue. But you see a great difference in the numbers there, the numbers of hours observed and the number of hours served. The research question is, the efficiency curves of the red and blue teams were recorded. Do the teams have equal mean efficiencies? Answers for the null hypotheses is yes, the efficiency of the red team is equal to the efficiency of the blue team. And for the alternative hypotheses, the answer is no. The efficiencies of the red and blue teams are not equal. Therefore, once again, we will reject the null hypotheses. The two teams do not equal the mean efficiency. And on visualization number 4, the correlational test. This is an XY graph, which just shows that the p-value is less than 0.001. That is a low p-value. However, on the upper and lower sides of the bar, we see that we have equal parts, and that there is a relationship between the weight and the miles per gallon. And in the study, it says a German study tested how larger industrial use vans utilize gasoline. One of their analyses plotted miles per gallon versus the weight of the various vans in the study. After plotting the data on a scatter plot, the researchers performed a correlational test and found a significant correlation. However, they forgot to state the hypothesis test in their published paper. So, the important question is, what were the study's null and alternative hypotheses? The answer is, the study on the null hypothesis, the study shows that there are no correlation between miles per gallon and the weight of the van. The van's weight does not affect its miles per gallon. In the alternative hypothesis, the weight of the van has an effect on the miles per gallon. There is a correlation between miles per gallon and the weight of the van. And so once again, we will reject the null hypothesis. So now we get to our important takeaways. With our important takeaways of creating the hypothesis test, we see that when creating hypothesis tests, you must understand the meaning of the terminology that's used. First of all, you need to know what it is before you can speak on it. And then understanding the questions being asked helps to determine how to apply the given information. And another takeaway is when the p-value is less than or equal to x, which is usually 0.0001, then the hypothesis is rejected in favor of the alternative hypothesis. If the p-value is greater than x, then the null hypothesis is not rejected. So now we'll go to using visualizations. Visualizations can help to conclude whether reject or agree with the null hypothesis. Visualizations also gives us a better view and understanding of data presented and being tested. Thank you all so much for watching. Certainly appreciate your time. If you have any questions, please place them in the discussion portal. Thank you again.